2 దశాబ్దాలుగా తెలంగాణ ఆంధ్రప్రదేశ్లో కాంపిటీటివ్ రంగంలో తిరుగులేని సంస్థ
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్.
తెలంగాణ గురుకుల టీచర్స్,
జేఎల్స్, డిఎల్స్,
టీజీటీ, పీజీటీ,
పీఈటీ, పీడీ,
లైబ్రేరియన్స్ కొరకు
స్టేట్ ర్యాంక్స్ తో పాటు వేల సంఖ్యలో అభ్యర్థులను ఉపాధ్యాయులుగా తీర్చిదిద్దిన
డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో
స్టేట్ ఫేమ్ ఫ్యాకల్టీస్ చే ఆన్లైన్ అండ్ ఆఫ్లైన్ బోధన అందించే ఏకైక సంస్థ
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్, దిల్సుఖ్నగర్, హైదరాబాద్.
100% నూతన సిలబస్ ఆధారంగా ఆఫ్లైన్ అండ్ ఆన్లైన్లలో బోధన.
ఆన్లైన్ కోచింగ్ కొరకు డౌన్లోడ్ చేయండి
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్ మొబైల్ యాప్,
ప్లే స్టోర్ అండ్ యాప్ స్టోర్లలో లభ్యం.
ఆన్లైన్ కోచింగ్ లో అన్ని కోర్సులు తక్కువ ఫీజుతో 1 ఇయర్ వ్యాలిడిటీతో పాటు 1 మంత్, 3 మంత్స్, 6 మంత్స్, 9 మంత్స్ వ్యాలిడిటీ ప్యాకేజీలు అందుబాటులో కలవు.
పూర్తి వివరాలకు సంప్రదించండి
9246208422 88855555202.
తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని, టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు, 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని ఎన్ సరిత, టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత, మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 డిఎస్సి ఎస్జిటిలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్, స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్ లో టీజీటీ మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, టీజీటీ బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, టీజీటీ సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, టీజీటీ సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, టీజీటీ తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, టీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, పీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, పీజీటీ ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 డిఎస్సి గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. డిఎస్సి గురుకుల టీచర్స్ మరియు గ్రూప్స్ ఎస్ఐ కానిస్టేబుల్స్ కోచింగ్ కొరకు డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422 8885555202 88585900 800895440 800895448 85208443.
Hello, how are you? Welcome to Ramaya Competitive Coaching Center. My name is Sathish, Chemistry faculty. So the Telangana state has announced junior lecturer posts in different various junior colleges in Telangana state. So today we are going to discuss the original content which is actually present in chemistry jail post. Example first, before going into the chemistry content, first I would like to explain the last date and how to apply and what are the age limits which are there for the jail examination. See here, submission of online application form is the 16th December 2022 and online application submission before 5 p.m. 1st January. The payment should be done before 1st January. So regarding chemistry, if you take chemistry total, in chemistry you have total 113 regular English medium posts and 19 Urdu medium posts are there. The age limit is minimum of 18 years, maximum of 44 years are there. And the pay scale for junior lecturers is around 54,222 to 1,33,630 rupees. This is the pay scale. Now, suppose if I take the age relaxations for all Telangana state government employees up to 5 years based on the length of regular service, for ex-servicemen 3 years, for NCC 3 years, and SC, ST, BC, EWS students 5 years, physically challenged persons it is 10 years. Next year, category wise number of posts. Number of posts, multi-zone 1, multi-zone 2. In OC, general 14, women 8. So like that you have total 113 posts are there throughout. 113 posts are there throughout the state. So this is about the number of posts regarding jail examination. And next we are going to discuss the paper set, the type of paper that we are going to face. Example, it consisting of total 2 papers, paper 1, paper 2. The paper 1 consisting of general studies and general ability. Total number of questions are 150. Duration of time is 150 minutes. Each question carries 1 mark, so 150 marks. Similarly, chemistry subject, the syllabus is up to PG level, not PG syllabus, up to PG level, and the number of questions coming from this are 150 and duration is also 150. Each question carries 2 marks, so total 300 marks. In this, total number of marks are 450 marks. Now here, except the languages, remaining all content subjects, concerned subjects are written only in the English language only in the English language. Now coming to syllabus. See here, so total chemistry includes 3 parts, majority inorganic, organic and physical. So first I would like to explain some important thing. So total portion, if you assume 100%, in this 60% of questions are coming from intermediate as well as degree standard. 60% of questions are coming from intermediate and degree syllabus, whereas 40% of syllabus is coming from PG level. And moreover, we have total for subject. For chemistry subject we have 150 questions are there. Among 60% means 90 questions. 90 questions related to intermediate as well as degree questions. And remaining 60 questions are coming from PG standard. If I am not wrong, each question carries 2 marks. So total 180 marks are coming from intermediate as well as degree, whereas from PG into 2 will get 120 marks. Total 300 marks. 180 plus 120, 300 marks. So this is the actual weightage. That means not actual exact, but tentative weightage is like this. Total 100% syllabus, it covers intermediate, degree as well as PG. So most of the cases what they are saying that they are giving that 60% of syllabus is covering from intermediate as well as degree portion or concepts related to degree and intermediate, and remaining 40% of portion is covering from PG syllabus. So in terms of number of questions, if you ask me that among 150 questions you have total, among these 150 questions, 90 questions are coming from degree standard or intermediate concept oriented questions. And 60 questions are coming from PG standard questions. So 90 questions, each question carry 2 marks. See here, 1 minute. See here. So these are number of questions and each question carry 2 marks. Total 180 marks are coming from degree and intermediate questions and 60 questions are there from PG standard, each carries 2 marks. 120 relatively they are PG standard questions. So if you concentrate more on the concepts of degree and intermediate, because if you are appearing JL examination, I can imagine that some of you are working in a different type of corporate or other colleges which are related to intermediate or degree. So you are familiar with this syllabus. So if you go through the syllabus with this particular syllabus clearly, you can score 180 marks in the subject and at least 50% of syllabus from that you will score 60 marks, 240 seat getting or job getting marks. Now see here, coming to the syllabus. So in the inorganic chemistry we have first atomic structure and chemical bonding. So in case of atomic structure, the nature of bonding between atoms based on hybridization, valence shell electron pair repulsion theory, right? Molecular orbital theory also. It explains different, that is, see here, applications based on Vesper theory, valence shell electron based theory, valency bond theory and molecular orbital theory. If you concentrate more on this particular area, compulsory a question is coming from that area, atomic structure, that is chemical bond. Next, groups. In the inorganic chemistry, the majority is given for groups from first A to 0 group elements or noble gas elements. Main group theory. So what I mean to say is, if you concentrate more on groups and the syllabus which is there for groups is based completely on their properties, physical properties. So what actually the physical properties of elements explains? How to prepare that groups I will explain here clearly. See here. See here. 1 minute. In groups, rather than studying the groups in a individual manner, if you prepare the groups in a comparative manner, it becomes very easy to understand the properties and also time saving process. Suppose say you can classify the groups into first S block and P block. In case of first S block, you have first A and second A. In case of P block, we have like this: third A group elements, fourth A, fifth, sixth, seventh, and noble gases. Now, how to prepare these properties in a comparative study? What I mean to say is, suppose if you are concentrating on S block, first take like this: physical property, atomic size. Take any one of the important book, how the atomic values, each group, every group at the starting of the lesson, you will have a tabular form. That tabular form summarizes the total physical properties of elements. I am not saying that don't by heart all the numerical values which are there in the tabular form. I am not saying that. Just simply observe the numerical values. Just simply observe the numerical values and how they are changing, identify that one. Whether they are in the increasing order or decreasing order, try to write that one. Suppose example, atomic size. In case of first A, atomic size gradually increases. Second A gradually increases. third A gradually increases, fourth A increases, fifth A increases, sixth A increases, seventh A increases, eighth A increases. Suppose if it is electronegativity or electron affinity, for these elements we don't consider electron affinity, but for these elements electron affinity gradually decreases. Here one important thing is the first element gradually decreases means what? First element will have lesser value when compared to second element, but the second element will have more when compared to first. This is a general trend. Suppose example, if you take fluorine 7th group elements, fluorine, chlorine, bromine, iodine, these are the elements, electron affinity order is like this. That means fluorine, instead of fluorine, chlorine will have most electron affinity value. That you will observe by seeing the values present in the tabular form. Try to identify that one. It is not gradually decreasing. So what is happening? First element will have more. Afterwards fluorine, bromine and iodine. But in case of 6th A, you will find like this. Sulfur should have more. Compulsory it will have more. After sulfur you have to get oxygen, but you won't get oxygen here. Oxygen you won't get here. Sulfur, selenium, tellurium, polonium and oxygen. See, 7th group, 6th group, lot of variation is there. Second element is showing more, here also second element is showing more. But first element is showing more when compared to third element, but first element is showing lowest value when compared with all the elements. So such type of observations you will observe in the tabular form. So this completes in very quick time and very less time you can practice more number of concepts. That is group theory or inorganic groups. See here. Now like this you will have group theory. That means if you learn or if you prepare inorganic groups in the manner of comparative manner, within no time you can practice all the properties. Hardly you will have 10 or 11 properties. By observing all these values, hardly you will get 1 hour. In 1 hour time you will get all the properties of all the P block elements. Only required is specified group elements. Suppose example, oxy acids of these elements are there. Example, if I take oxy acids of elements, 1 minute. Oxy acids of elements we have. Suppose HClO4 is there in the group theory, 7th group elements if I consider. 7th group elements. So it produces HClO3, HClO4, O2 and HOCl. Instead of chlorine, if you write bromine, then you will get different type. And all these categories can be written as HClO4, HClO3 and HClO2, HXO2 and HXO. So compare like this. Oxidation state of central atom +7, +5, +4, +3, +1. So as oxidation state decreases, acidic nature decreases, oxidizing ability gradually increases. So such type of concept you can learn clearly by comparative study of inorganic groups. Comparative study of inorganic groups. Now, so this is second part. In the third part of inorganic chemistry, transition elements, D block and F block elements. D block and F block elements. So all the properties you may compare, especially in transition elements and inner transition elements. Oxidation property, magnetic property, color properties are very, very, very important. And next one, metallurgy. So the total metallurgical process includes this total metallurgy, all the whatever the syllabus which is there here, it is completely in your intermediate syllabus only. Whatever the syllabus, magnetic separation, fourth flotation, leaching process, liquefaction process, afterwards what we have, concentration of ore, oxides, reduction process, ivanni kuda thermodynamic principle, Ellingham diagram, and this Ellingham diagram is very, very, very important as per your examination concern. Ellingham diagram and extraction of iron, copper. In this iron, the percentage of carbon in different type of irons, pig iron, cast iron, rough iron are there. So the percentages. Next one, all the refining process, especially the alloys. Alloys of these elements includes ferrous alloys, non-ferrous alloys. If you see the old version of intermediate textbook, you will find all these concepts. All of these concepts are present in the old version of, because the new version of intermediate textbook, you don't have this alloy concept. So this is the first one, that is inorganic chemistry, first slide. Next, we have coordination chemistry. This is somewhat very important lesson regarding inorganic chemistry. In the coordination chemistry, we have a UPSC nomenclature, valency bond theory and crystal field theory, and splitting of d orbitals in various type of geometries is very important, and John-Teller distortion, right? Russell-Saunders coupling reactions, and all these are very important reactions. And most importantly, EAN of polynuclear complexes, right? Werner theory applications are very important regarding coordination compounds, except this area, Russell-Saunders coupling, except that area, remaining you will find in your intermediate syllabus only. Next, stability of metal complexes. So this is hard acids and soft acids. So Clatherate effect or chelation effect. It is also related to some part of coordination compound, but based on some reaction mechanism. See here, the reaction mechanism of complex compounds. Here we will get inert, and this is completely PG syllabus. So this particular area is completely your PG syllabus. So up to here 7 lessons. In the inorganic chemistry we discussed now 7 lessons. Among all these 7, except this seventh, remaining all are there in the intermediate as well as degree syllabus only. Next one, metal carbonyls, nitrosyls, metalloid structures of bonding, bioinorganic chemistry, where structure of hemoglobin, chlorophyll, the structures are very important. Next, analytical chemistry, right? You can expect a question from this area. In chromatography, there are different methods are there, but high preference liquid chromatography, gas chromatography, or very thin layer chromatography. Application part of this is very important. Thin chromatography, and don't expect very standard question, direct theory based questions only you will have in this. So this is about your inorganic chemistry. And coming to physical chemistry. So somewhat most of the BZC students who completed their PG as chemistry, they have some weakness of this physical chemistry, but mind you, the physical chemistry is very logical and very easy point of syllabus is there. See here, solutions and colligative properties. So in solutions, if you concentrate on expressing concentration terms, different type of terms are there: mass percentage, volume percentage, strength of solution, molarity, normality, formality, mole fraction, parts per million, all these are there. ppm, ppb also is there, parts per billion is also there, in terms of volume is there, in terms of weight is also there. All the numerical questions you can ask here. And afterwards, gas solubility in liquid, solubility of gas in liquid, Henry's law. Next, vapor pressure concept, and 4 important colligative properties based on Van 't Hoff factor. 4 important colligative properties, that is relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. These are 4 colligative properties are there. And before that, the Raoult's law concept is very, very important. That is, ideal solution, this is Raoult's law, a special case in that one, ideal and non-ideal solutions are very, very important area. Whatever the areas we are underlined, if you concentrate on those areas, then you will get compulsory a question from, you can solve a compulsory question from solution and colligative property. Very easy lesson, and simple way of questions are asked. I will discuss one important question like this. Example, suppose if you have osmotic pressure is there, or any colligative property we have. Example, delta P by P naught is relative lowering of vapor pressure. Delta TB, elevation in boiling point. Delta TF, depression in freezing point. Pi, osmotic pressure. All of them are colligative properties directly proportional to number of particles. So the conceptual questions can be asked like this. They will give four examples like this. 0.1 m glucose, 0.1 m sodium carbonate, 0.1 m magnesium sulfate, 0.1 m aluminium sulfate. Like this, they will give 4 or 5 options, that means compounds, and ask you to calculate how arrange them in the increasing order of their boiling point or that one, whatever it may be. For if it is not given, you need to understand that number of particles is equals to 100% ionization to number of particles is equals to 3 plus 2, 5. As the number of particles increases, any colligative property you take increases. So based on that, you can calculate, you can solve the problems related to colligative properties. Right? So this is first part of physical chemistry. The second part of physical chemistry is, see here, acids and bases. Here, in case of acids and bases, we have theories of acids and base, Arrhenius acid-base theory, Bronsted-Lowry acid-base theory, and Lewis acid-base theory. See here, Arrhenius, Bronsted, and Lewis acid-base theory. Afterwards, degree of dissociation of acids and bases, their ionization constant, that is Ka, pKa values, pH problems, buffer solutions. Buffer solutions is also there. 1 minute. Buffer solutions and salt hydrolysis is also there, and common ion effect related to solubility of gas substances. And this is very important lesson. And mind you, regarding entrance in this examination, the thermodynamics is the most important lesson. From here, you can get a bunch of questions based related to, most importantly, the coming from what we call entropy concept, and chemical thermodynamics is also there. The chemical thermodynamics means like this: evolution of absolute entropy. This is total thermodynamic concept. Gibbs free energy, chemical thermodynamics relations. This is delta H, delta S, signs, right? That means during the chemical reactions, how the delta H, delta S are going to change. If it is spontaneous or non-spontaneous, right? The spontaneous process or non-spontaneous process. Then what are the signs of delta S and delta H? Or sometimes delta G relations are also asked, right? So this is about thermodynamics. Next one, we have electrochemistry. In case of electrochemistry, we have conductance and its application, deviation from Nernst equation, chemical and concentration cells, liquid junction potential, that is applications of EMF, right? On the base of that solubility. Next, Debye-Hugel-Ansager equation, conductance, electrolytic conductance, electronic theory of conductance, calculation of ionic activity, transport number, right? All these are very, very important in electrochemistry. So the first part of this one from intermediate syllabus you can get, and the remaining part is from degree syllabus, right? The applications of Dilsukhnagar equation, and afterwards quantum mechanics. So we can say this is applications of Schrodinger wave equation, black body radiation, dual nature of electron, and Heisenberg uncertainty principle, right? On the base of that, quantum numbers are also important, right? So this is which one? Schrodinger wave equation. Application of Schrodinger wave equation. On the base of that, the distance of nodes which are appearing in the different type of orbitals can be established. Most important lesson. And next one, chemical kinetics. So chemical kinetics, total, that means rate law, rate constant, that concept is not there in this, but the theories of unimolecular, bimolecular, activation energy, transition state theory, all this theory, that means the collision theory and exothermic, endothermic concepts are there in case of chemical kinetics. Next, we have photochemistry. So photochemistry is a part of physical chemistry where you will have nearly about 30 marks are appearing in the examination. Relatively, this is the not exact value but the tentative value, right? So electronic transition theory of molecules, right? Fluorescence, phosphorescence, right? On the basis of this application in the organic chemistry also we have organic photochemistry is there. Including photochemistry and organic photochemistry you have 30 marks. 30 marks are asking from this area. Physical process, photophysical process, photochemical process, calculation of rate constant of various photochemical reactions. Photochemical reaction, applications of chemical kinetics is also there in this particular part, right? Polarized light, non-polarized light application part. So the experimental setup of photochemical cells and photochemical reactions are important regarding photochemistry. Most important lesson, almost 30 marks are coming from this lesson. The next one, another important concept is lesson in the physical chemistry is solid state. So in the solid state, all the concepts are there in your intermediate as well as degree standard. In degree standard you have Miller indices. This Miller indices is also not there in this syllabus. See here, HCP arrangement, CCP arrangement, right? Okay, this one, solid state chemistry. In the solid state chemistry, we have classification of solids and types of Bravais lattices, right? And X-ray crystallography methods, primitive body centered and face centered unit cells dimensions like their packing fraction, number of atoms covered, density, right? Similarly, in the packing fraction, close packing arrangements, CCP arrangement, that is one dimensional, two dimensional, three dimensional. One dimensional, two dimensional and three dimensional, as well as tetrahedron voids, octahedron voids, packing efficiency, right? All these concepts are there in this your intermediate as well as degree syllabus. HCP, CCP, ABC arrangement, AB type of arrangement. In that defects, Schottky defect, Frankel defect, that is stoichiometric defects are there, non-stoichiometric defects are there. All the stoichiometric defects, Schottky defect and Frankel defect. Non-stoichiometric defect, metal excess defect due to presence of extra cation, F centers, magnetic property is very, very important regarding solid state, right? In magnetic property, different type of theories also proposed in the magnetic property. And next one, conductors, that is eccentric semiconductors, incentric semiconductors. Based on that, preparation of N type of semiconductor, P type of semiconductors, all these are very, very important concepts are there in the solid state. And the next one is organic chemistry. So majority of the questions are coming from stereochemistry and some important chemical reactions. See here. Nomenclature of organic compounds, also isomerism. The isomerism, stereochemistry is also one of the important isomerism. You will get optical isomerism, you will get RS nomenclature, next EZ nomenclature, right? What we call criteria of chirality, wedge dash projection, Fisher projections, all these are there in organic chemistry. Stepwise you have to learn nomenclature, in that aliphatic, cyclic, aromatic, bicyclic, spiro, compulsory. Isomerism, chain, that is structural isomers, stereoisomers. In case of stereoisomers, conformational isomers as well as configurational isomers. In configurational isomers you have geometrical isomerism is there as well as optical isomerism is there. And this part, I mean to say, if you cover total isomerism, whatever the topics I explained here, it almost leads to this one. Alloxime, EZ nomenclature, cycloalkanes, geometrical isomerism, spirines, allenes, chirality, all these concepts are there. In the isomerism part only you come across this point. If you cover these three, almost organic chemistry is completed. Almost completed. Because next one, classification, preparation and properties of alkanes, alkenes, alkynes, cycloalkanes, aromatic hydrocarbons, halogen derivatives, hydroxy compounds and carbonyl compounds, carboxylic acid and its derivatives. Both it covers intermediate as well as degree syllabus. This total intermediate organic chemistry, total preparation of alkanes to up to carboxylic acids. This is organic chemistry, right? Afterwards, suppose in case of organic chemistry, suppose if you want to discuss allenes, so the allene concept is very, very important. If you have like this, so this carbon is sp2 hybridized, this carbon is sp hybridized, this is sp2 hybridized. So what happens if this is present in this manner and the other double bond is present in this manner? So one double bond and another double bond are present perpendicular to each other. Because of that, they do not produce mirror images. If you have even number of double bonds are there, compulsory mirror images are with non-superimposability are there. With odd number, you will have superimposability is there. Because for odd number, you will get what? Suppose if I write another one more thing, one more alkyl halide carbon if I write in allene, what happens? Three double bonds are there. The third double bond is written like this. If you keep mirror here, you will find exactly. So such type of concepts are relatively very, very important regarding isomerism part, which is there in organic chemistry. Next, see here. This is also one part of isomerism. Conformational isomerism, torsional strain, cycloalkane, geometrical isomers are also there. Chair conformation, board conformation, right? Angle strain, dihedral angle, stereoisomerism, study of conformation isomers of acyclic compounds like ethane, butane, dihalobutane, halohydrine, ethylene glycol, 2,3 diol, butane diol, amino alcohols. So the intention is here somewhere hydrogen bonding is possible. Hydrogen bonding is possible, because of that the Gaussian conformations are said to be more stable when compared with staggered conformation. Intention is that one. And the energy difference between Gaussian form, staggered form, partially eclipsed form and fully eclipsed form of ethane and butane are very, very important. The energy values are there. Those values are also very, very important. Along with this, you can also study cycloalkane, cycloalkanes, geometrical isomers. So cycloalkanes, in case of that cycloalkane, the most important example is cyclohexane, which has relatively 4 important conformations are there. One is chair conformation, twisted boat, boat conformation and off chair conformation. So in this, relatively more stable is this one. So in this, if you have like this, if the bonds are written in this manner, so these are said to be axial bonds, right? If I write other type of bonds perpendicular to this, equatorial bonds. Equatorial bonds. These are equatorial bonds. E stands for equatorial and A stands for axial. So all axial bonds are said to be less stable when compared with the equatorial. On the basis of that, 1, 2, 1, 4, both axial or both equatorial. The isomer is called a trans isomer. 1, 2, 1, 4. One is axial, another one is equatorial. Is said to be cis isomer. For 1, 3, it is a different scenario. Such type of isomerism also is very, very important regarding conformational isomers of cycloalkanes. Afterwards, reaction mechanism. Before going into reaction mechanism, we have some more important concepts is there. Bonding in organic molecules. Aromatic character 4n plus 2 pi electron rule. Anti-aromatic character 4n pi electron rule. If these two rules are not satisfied, a non-aromatic character. And the order of stability also very, very important. Delocalization of chemical bond, conjugation, cross conjugation, resonance, hyperconjugation, tautomerism, Huckel rule, concept of aromaticity, anti-aromatic character, non-aromatic character. All these concepts are very, very important. As per your, that means if you prepare up to 5 chapters of this organic chemistry, tentatively, suppose say total 150 questions are there, each area consisting of 50 questions. Suppose say 50 questions, among those 50 questions, organic chemistry 50 questions, majority of 30 questions are coming from only this area. 30 to 35, easily, right? Next one, reaction intermediates. So in case of reaction intermediates, how a intermediate is generated, like electrophile, nucleophile, radical, carbene, nitrene, benzene, right? See here, carbanion, free radical, carbene, nitrene, benzene is not there here. Classification of what we call all reaction intermediates, right? Afterwards, some important chemical rearrangement reactions. Electron deficient carbon, Mervyn Pandraff. Next one, pinacol-pinacalone rearrangement, allylic and Wolff rearrangement, electron deficient nitrogen, Hoffman. That means electron deficient carbon rearrangements are these. Electron deficient nitrogen rearrangements are Hoffman, Lawson, Curtius, Smith, Beckman rearrangement. All these are. Electron deficient oxygen, Baeyer-Villiger oxidation, right? Base catalyzed rearrangement, benzoic acid rearrangement, right? Favorowski reaction. All these are very, very important rearrangement reaction. In Sanyl and Sanyl, a book name called Sanyl and Sanyl, you will find all these rearrangements. All the named reactions are included in that book. Next, reaction mechanism. In the reaction mechanism, addition reaction, substitution reaction and elimination reactions are very, very important. In case of elimination, I mean to say this is alpha elimination reaction, right? Yeah. In case of elimination, unimolecular, bimolecular, unimolecular, conjugate base, right? Similarly, elimination reactions those are. Next one, substitution reactions, along with their stereochemistry you have to learn. And some important named reactions are there, oxidation reactions. Swern oxidation, oxidative cleavage of 1, 2 diols, periodic acid, right? Lead tetraestate. By using these reagents, how oxidation phenomena is going to be take place in organic reactions. And in this, in case of this particular reaction mechanism, the stereochemistry aspects are very, very important. Stereochemistry aspects are very, very important regarding this. And always elimination reactions are concentrated more here, but it also important substitution reaction, addition reactions also. Markovnikov rule, anti-Markovnikov rule, stability of carbocations, all they are very, very important. And next one, reduction. Earlier we discussed oxidation, now reduction. Wilkinson catalyst with lithium aluminum hydride, with sodium borohydride, and with sodium borohydride, with lithium aluminium hydride, boron diborane, sodium borohydride, right? HBO reaction, oxymercuration, demercuration with diabol H. All these reactions are reduction reactions and heterocyclic chemistry. In case of heterocyclic chemistry, the importance of drugs, nomenclature of heterocyclic compounds, right? Classification based on size of the ring, number and nature of heterocyclic atom. If nitrogen is there, azo, sulfur is there, thio, like that, right? Synthesis of ferrol, furan, thiophene, pyridine, indole, benzothiophene, quinoline, isoquinoline. I think you have all these compounds, preparation and properties of all these heterocyclic compounds in your degree syllabus. And this is related to PG. Alkaloids and terpenoids, right? There are some drugs, terpenes, isoprene, natural rubber, right? Neoprene. Next one, importance of drugs, isolation of natural products, right? With steam distillation, solvent extraction method, all these are very, very important. And next one, organic photochemistry. As I told earlier, that photochemistry based on fluorescence, phosphorescence, the mechanism taking place in presence of light. Based on that, you have alpha beta unsaturated ketone cyclo, that is organic chemistry. Photochemistry includes energy profile diagram, first principle, Jablonski diagram, electronic transition, photosensitization. Next, how to yield? See here, this is NB star, P star, P star transition, Norris type, Norris 2 type, cleavage of bond. In this Birch reduction is also one of the important reaction is there. Alpha beta unsaturated compounds, that is ketones, how they react. 1,3 butadiene, 2+2 addition, right? Diparamethane rearrangement, photochemistry, aromatic compounds, excited states, 1, 2, 1, 4 addition reactions. When you have non-conjugation, you have 1, 2. If you have conjugation, you have 1, 4 addition reaction. So slightly this is also important. Photochemistry and organic photochemistry both includes total 30 marks. And next we have finally pericyclic compounds, right? So with location of based on stereochemistry, the pericyclic reactions on the basis of molecular orbital theory, symmetry of ethylene molecule, 1, 3 butadiene and 1, 3, 5 hexatriene, allylic, all these are pericyclic reactions. This is also completely PG related topic. Basic principles of concepts of UV, IR, proton NMR, C-13 NMR and mass spectroscopy, all these are, and application parts. Means you have to remember some important values of each and every functional group and each and every, suppose proton is there. Different type of protons are there. Tertiary proton will have a peak, secondary proton will have a peak, primary proton will have a peak at different peaks in hydrogen NMR, right? So based on that values, you have to predict whether it is tertiary amine or tertiary hydrogen or primary hydrogen or singlet hydrogen or doublet hydrogen, like that. So this is also PG related topic. And green chemistry, that is principles of green chemistry and its approach towards nature, and also important. But application oriented, this is very, very important. But most importantly, all this together, if you see all the total content, if you see in the organic chemistry, last four topics, I think 1, 2, 3 and 4. The last 4 topics are related to PG syllabus and remaining all are related to based on intermediate and degree standard only. Hope you understand the content and which part is more important and from where the questions are asked. We clearly explained, and hope you all understood this concept. Mind you, and one more important thing is, every area of organic chemistry is very important. All the areas, around 60% of questions are coming from your intermediate and degree standard, right? So this is about the content in junior lecturer post for Telangana state. Okay, thank you.
రెండు దశాబ్దాలుగా తెలంగాణ ఆంధ్రప్రదేశ్లో కాంపిటీటివ్ రంగంలో తిరుగులేని సంస్థ
రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్.
తెలంగాణ గురుకుల టీచర్స్,
జేఎల్స్, డిఎల్స్,
టీజీటీ, పీజీటీ,
పీఈటీ, పీడీ,
లైబ్రేరియన్స్ కొరకు
స్టేట్ ర్యాంక్స్ తో పాటు వేల సంఖ్యలో అభ్యర్థులను ఉపాధ్యాయులుగా తీర్చిదిద్దిన
డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో
స్టేట్ ఫేమ్ ఫ్యాకల్టీస్ చే ఆన్లైన్ అండ్ ఆఫ్లైన్ బోధన అందించే ఏకైక సంస్థ
రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్, దిల్సుఖ్నగర్, హైదరాబాద్.
100% నూతన సిలబస్ ఆధారంగా ఆఫ్లైన్ అండ్ ఆన్లైన్లలో బోధన.
ఆన్లైన్ కోచింగ్ కొరకు డౌన్లోడ్ చేయండి.
రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ మొబైల్ యాప్,
ప్లే స్టోర్ అండ్ యాప్ స్టోర్లలో లభ్యం.
ఆన్లైన్ కోచింగ్ లో అన్ని కోర్సులు తక్కువ ఫీజుతో 1 ఇయర్ వ్యాలిడిటీతో పాటు 1 మంత్, 3 మంత్స్, 6 మంత్స్, 9 మంత్స్ వ్యాలిడిటీ ప్యాకేజీలు అందుబాటులో కలవు.
పూర్తి వివరాలకు సంప్రదించండి
9246208422 8885555202.
తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని. టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు, 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని ఎన్ సరిత. టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత. మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 డిఎస్సి ఎస్జిటిలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్. స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్ లో టీజీటీ మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, టీజీటీ బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, టీజీటీ సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, టీజీటీ సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, టీజీటీ తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, టీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, పీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, పీజీటీ ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 డిఎస్సి గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. డిఎస్సి గురుకుల టీచర్స్ మరియు గ్రూప్స్ ఎస్ఐ కానిస్టేబుల్స్ కోచింగ్ కొరకు డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422 8885555202 88585900 800895440 800895448 8520844463.